You're listening to STEMxm, where women in science, technology, engineering and mathematics share their stories of success, overcoming barriers, and breaking the glass ceiling. And now, your host, Mel the Engineer.
Hello everyone, and welcome to episode 1 of the STEMxm podcast. Today we have an electrical engineer, Jill Tietjen, with us. Jill has worked over 35 years in the electric utility industry, providing thought leadership, consulting services, and serving as an expert witness before regulatory bodies. She has served in leadership roles for both the National Women's Hall of Fame and for the Society of Women Engineers. Jill is an advocate and champion for women in STEM. A great part of her time has been dedicated to writing to remind women that they can achieve personal success through passion, determination, and persistence. She is the author and co-author of 6 books and over 100 articles, many of which are about women in engineering and women in STEM. And we discuss these in the interview. Also, I've got show notes put together for all of these resources that we talk about. You can find those at stemxm.com/episode 1. Right now, let's get into the interview with Jill, and I'll be back here with you at the end of the show to wrap up any loose ends. Thank you, Jill, for joining us, and welcome to STEMxm.
Good morning, Melissa. It's such a pleasure to be here.
Thank you. So I'm going to dive right in. You're an electrical engineer, and you're the first electrical engineer that I've had on the show. So if we could go right into that, could you tell us an overview of what it's like to earn an electrical engineering degree, and then maybe give us a brief overview of some of the different career path options that are available?
Well, I just want to clarify one thing. I actually have a degree in applied mathematics with a minor in electrical engineering. Since I'm a licensed professional engineer, I have to have some field that I'm associated with. And since I've spent my career in the electric utility industry, I call myself an electrical engineer. It's so fascinating. I'm a member of the Institute of Electrical and Electronics Engineers, and there are 39 separate societies within the umbrella of what's called the IEEE. So there are so many different fields and avenues that an electrical engineer can pursue. As I said, I'm in the electric utility industry where I've spent 40 years, and the whole purpose of the electrical utility industry is to make sure that we have safe, economic, and reliable power for all of the many uses for which we put electricity to. But other areas of electrical engineering, and it's amazing because we can barely speak to each other, all of the other electrical engineers in the field. There's all of television, telecommunications, computers, the little RFID tags that are now on our credit cards. It's all of that stuff, and I'm sure that I'm leaving out so many different areas that are related to electrical engineering. So, it's a very, very diverse field, both the software and the hardware associated with the computers, everything to do with smartphones and telephones and the integrated chips that are in our phones. All of that is electrical engineering.
So I've got a couple questions from what you just described there. Can you tell us, why did you do applied mathematics, and how does that help funnel you onto the path that you got onto?
Well, I ended up in applied mathematics because when I graduated from high school in 1972, engineering was not really a career that anyone thought that women should be in. So no one actually suggested to me that I think about engineering as a career. And I was very, very strong in math. So I actually entered the University of Virginia as a math major. And as I looked at what career options were available to me, those were not very appealing. I didn't actually want to be a teacher. And when I saw what the students that I knew were doing in engineering, that was what I wanted to do. So I looked at the majors that were available at the University of Virginia in the School of Engineering and Applied Science. And at that time, and I should say not today, but at that time, there was an applied mathematics degree, and my father's PhD was in applied mechanics. His undergraduate was in mechanical engineering, and his master's was in aerospace engineering, and his PhD was in applied mechanics. So I thought, applied mathematics, that actually really sounds good. And then having an applied math major required an engineering minor in the School of Engineering and Applied Science. So I picked electrical because it's very, very strong math skills required for electrical engineering, and that was interesting to me. And so that's kind of how I picked it. Now, what I will tell you is that in my career, I started doing simulation models almost from the beginning when I went to work at Duke Power. So having that math degree in combination with the electrical engineering minor actually really served me very well in my career.
And can you describe for us what you mean by simulation models?
Absolutely. A simulation model is computer software that has data and information about every existing power plant in an electric utility system. So the size of the power plant, the kind of fuel that it uses, the efficiency of its use of that fuel, how much it costs the fuel, how much it costs to operate the unit. And then the simulation model actually simulates the operation of the electric utility system. And actually the models that we used went out 20 years looking at how the generating units would be operated to meet your and my requirements for electricity.
Wow, that sounds very cool. So that's something integral to the planning for a utility, it sounds like.
Right. There are actually two different pieces that are integral to the planning just for the power plants, which is called generation. There are also very important models and data required to model the big power lines on those big towers. That's what's called transmission. And then on the wood poles and in our neighborhoods, and that's called distribution. And in the generation, which is the power plants, we actually had two kinds of models. One is called production costing models, and that's what looks at, let's just use as an example, this year. So we would look at what all the fuel costs were this year and what all the operational factors were for this year. And we would do the cost of production of electricity. That's why it's called a production costing model. And then we had something that was called capacity expansion models. And that's what looked at 20 years into the future if your and my need for electricity and all of the commercial people, that's like Target and Walmart and all that kind of stuff, and then the factories and the industrial customers, as that demand and requirement for electricity changed over the 20 years, at what point in time in the future were there going to be needs for capacity expansion, new power plants? And so we had production costing and capacity expansion models, and I ran both of them.
Very cool. Can you talk to us about what drew you to the power utility industry to begin with?
Well, the truth is I was not drawn to the electric or utility or power utility industry. It's one of those life things. I was actually engaged at the time, and my first husband was a nuclear engineer, and Duke Power really wanted him. And in order to get him, they had to hire me. And it was just the most perfect match for me. It has been a fabulous career. It matches my personality so well. When I went to Duke Power at the beginning, which was the first 5 years of my career, Duke Power's, let's call it their motto, contained two words, and that was community and service. And that just matched who I was and where I was in my life and my career so well. And then to have had the pleasure of all these years of making sure that electricity is delivered, because it's something that we actually don't even think about. We just flip the switch and the appliance or whatever it is goes on, the light goes on, the stove goes on, the refrigerator operates, the alarm clock works. And to have that ability just to know that that's what I do. I help keep the lights on. That's actually been really, really important to me.
Yeah, that's fantastic. It sounds like that was a happy, serendipitous thing in life to fall into for you.
Yes, it really was. And after my 5 years at Duke Power, my first husband and I moved to Denver, where I worked in the coal industry for a little over 3 years. And then I went into the consulting business, where I actually did planning and oversaw planning activities and helped in planning activities for electric utilities, as well as now with my fuel background, also understanding the fuel requirements and the fuel needs of those utilities. So it really has been, yes, serendipitous, I think, is exactly the correct word, and it really worked well for me.
So one of my main motivators for doing this show is that when you grow up in a small town and maybe your parents aren't in a STEM field or whatever the situation might be, it's difficult to know if a career path that maybe you're interested in, it's just difficult to know if it could be right for you if you haven't met anyone that's doing it and you don't have access to that. So you just described how you kind of luckily got into the power sector. If you were going to speak to the young people who are maybe interested in this, but they don't know anyone in the power sector and they don't know if it would be right for them, what would you tell them, and how would you describe working in this particular industry?
Well, I'm actually going to use words from my second husband. We've been married now 20 years. And even when we were dating, he was coming to industry conferences in the electric utility sector. And now he comes with me. I sit on a corporate board of a utility, and he comes with me to the strategic planning sessions for that utility. And he says that these people that I work with, that I'm affiliated with in this industry, are the salt of the earth. And what that means is that for me and the people that I work with, the most important thing that we can do is to make sure that everyone else, well, us too, of course, but everyone else has electricity. So it's a very altruistic field. And yes, there's a regulatory component, and yes, a lot of people have heard that coal is bad and that coal is dirty, but let me just tell you that we are so far ahead of where this country was 100 years ago, 150 years ago, when we didn't have electricity and the benefits that come from electricity. And so what I say to students, and I speak all over the U.S. and I talk to students, is I talk to them about the value of infrastructure. And what I mean by that are the roads, including the stoplights and the on-ramps on the interstates and the airports and the water system. Most of us have water. We just turn on the faucet and we have clean water that comes into our house. And the electricity and television and the communication systems and smartphones, all of that is actually what I consider my industry, the whole infrastructure industry. We don't produce, or I don't, and very few people that are listening to the show produce their own clothes or grow their own food or all of their own food or all of their own clothes. And they didn't make the beds that are in their house, and they didn't make a lot of the products that they use. And all of those products were touched by engineers, and all of them were touched by infrastructure because they had to be packaged and transported in some way to wherever people purchased those products, whether it was food at the grocery store or items in their home from a department store or a Walmart or a Target. Nothing got there by accident, and there are many, many, many steps along the way, almost all of which, or maybe all of which, engineers had something to do with. So we, as engineers and STEM people, provide tremendous value, and there are so many opportunities in each of these different areas for someone to consider.
That's a really good overview. Thank you for describing that. So you've done a lot of outreach over the years, and especially to encourage women to pursue engineering and STEM fields. Can you talk to us about some of that outreach, and what have you done that has excited you the most, or which piece of that are you the most passionate about?
I have been doing outreach for particularly young women to consider careers in the STEM fields since 1979. And the program there are two programs that I would say are most interesting and most exciting to me. And I'll do the easier one first. And that is scholarships. Scholarships for people to attend college so that they can get the necessary educational background to become an engineer. And I helped establish scholarships as early as the mid-1980s to ensure that there was money to assist people in their pursuit of an education. And then the other program, which has actually been life-determining for me, was in 1987. I heard about a program which was an essay contest on great women in engineering and science. And we decided to do that here in Denver, Colorado, for all of the sixth grade students in the states of Colorado and Wyoming. And this is 1987, so the first year that it was offered was 1988. This is before the internet. And this is when we had to put flyers together and mail them to the schools, encouraging students to submit essays on one of 5 historical women in engineering and science. And then we had to do all of the research on those women and to figure out, in fact, a wider array of women than the 5, to pick 5 out of that wider array, to do the research on all of those women so that we knew what the facts were so we could judge the essays, and then to disseminate the information to award the prizes to meet the students. And it's been life-determining for me because then I started nominating some of those women for awards, some posthumously and some who were still alive. And that actually led me to some of the books that I've written. But I will tell you that one of the very exciting things about this essay contest is there is now a woman who is a national officer of the Society of Women Engineers. She actually still lives here in Colorado, and she was one of the 6th grade students that wrote an essay way back when she was in 6th grade.
Oh, wow. That is really amazing.
Yeah, she's a friend of mine. Actually, she considers me one of her mentors. And it's just so exciting when she said that, yeah, she had written, I don't remember who she wrote it on, but that she had written one of those essays way, way back when, and that now she's a national officer. I just got some email information. She was on Capitol Hill talking to senators and representatives, and she's doing us all proud.
Wow, that's really amazing. Would you like to tell us about some of the books you've written?
Oh, absolutely. I actually have a book coming out it'll be probably out in August. And it's a history of women in engineering. It's a revision of an earlier book that I wrote, which was also a history of women in engineering. And of course, that is based on the work that I did, or that I started doing, for that essay contest. I also have an Introduction to Engineering textbook, which is used by students in college who are taking an Introduction to Engineering class. I have a book that was published in January by the IEEE, the Institute of Electrical and Electronics Engineers. It's an ebook, and it's actually a little bit of my life story plus some of my life lessons. And it's called Recognizing and Taking Advantage of Opportunities. And then I have a best-selling and award-winning book that's called Her Story, A Timeline of the Women Who Changed America, which is over 850 women across all fields of endeavor from 1587 to 2011. And that's actually a HarperCollins book with a foreword by Madeleine Albright. And I have there are some other books. There were 3 books actually in the Setting the Record Straight series, of which the History of Women in Engineering, the original History of Women in Engineering, is one of them. And so it's just been amazing to me when I look back to see that that essay contest was so important in my life development.
Yeah, that really spurred a lot of things. That's so amazing. And these books, they sound so interesting. In the History of Women Engineering revision that's coming out, what did you add to that, or what changed in this new edition?
What I changed in the edition was I added more women to make it absolutely as diverse as I possibly could, so that it was inclusive across every way that we can sort of define diversity and inclusiveness. And then the last chapter is actually pretty forward-looking in terms of what are the major areas of research and activity and interest in engineering, from nanomaterials to biomedical stuff, leading to the other volumes. That book is actually the first volume in a series of books. This is published by Springer, and each subsequent volume will have a volume editor who is a woman on a topic within the engineering and science fields. Each chapter in the book will be written by women and will talk about their work in the field and kind of advances in the field. And so far we have 1 volume in sustainable agriculture and food biotechnology, 1 volume in controls, 1 volume in electric transmission and distribution, a volume in cybersecurity, a volume on thermodynamics, and a volume in nanotechnology. And then I'll be talking next week to a woman who I believe will end up being the volume editor for the volume on biomedical engineering. So it's very interesting and very exciting to be able to provide women with an opportunity to talk about not only very exciting advances in their field, why they got into the field will be part of it, and a little bit about how they've been interested and why they're excited to be there.
That's great. So I've taken notes, and I will definitely put links to all of your books in the show notes so our listeners can go and find each of them there.
Cool.
I want to kind of come back down from the high level discussion and come back to your personal career. Could you walk us through the places that you've worked and the type of work that you've done, maybe post Duke? Duke was your first job out of college. What was your path like after that?
My first husband and I started snow skiing in North Carolina. And we decided that we liked skiing and that we also were ready to move on. And so we decided we were going to move to Denver, Colorado. And I went to work for a firm called, well, it was Mobil Oil Corporation. Today it's now part of ExxonMobil. And Mobil Oil Corporation had a mining and coal division in Denver. And I went to work for their mining and coal division. And what I did there was also planning work. I did a lot of analysis about the need for coal at utilities around the country, as well as actually internationally. I looked at coal in Australia and Indonesia and in Colombia particularly. And then because Mobil's primary mining operation, which wasn't functional at that point in time yet, was going to be in the what's called the Powder River Basin area of Wyoming, I actually was involved with an effort that looked at that a company built a model for us that took existing design parameters of boilers at coal units and from an engineering viewpoint looked at the differences that would need to be made to those boilers and those power plants to handle the coal from Wyoming instead of the coal for which they had been designed. And I don't know that listeners are going to be aware that there are multiple different kinds of coal. There's anthracite, there's bituminous coal, there's subbituminous coal, and there's lignite. And each of those different kinds of coals also have variations between them and among them that relate to their sulfur content and their water content and their ash content and many other parameters. And so that particular model, very interestingly, that was actually started, for which I was the project manager when I was at Mobil, is now an industry standard. So I spent a little over 3 years at Mobil, and then I started my consulting career at Stone & Webster Management Consultants.
Okay.
Okay.
I'm sorry. Before you go further there, I've got several questions for you on what you just described. So, for our listeners, there's also mining engineering, which is a totally separate type of degrees. And so, I was wondering, did you have to work with mining engineers, and was that difficult? And was there a learning curve there for what you described about learning these different types of coal?
I did actually work with mining engineers, and I don't remember it as being difficult at all. There certainly was learning that was required, and this is where I will put in the statement that for any listener who thinks that once they're done with college, that they're done with learning, that is absolutely, positively not the case. That one of the things that college programs are now doing is saying that lifelong learning is very, very important for engineers, and that all of us actually need to continue to learn. I actually find that learning is exciting. I don't find that it's difficult. And that to learn about the different mining techniques, and there are different mining techniques for different types of coal and different reserves of coal, depending on how far beneath the surface they are, or if they're close to the surface or deeper. And so actually, and all the different mining equipment. So I didn't find that difficult. I actually found it very, very interesting.
Compared to your responsibilities, what were the mining engineers responsible for doing?
The mining engineers were responsible primarily, although some of them were actually also in planning with me. So it's not just that you get a certain kind of degree and then you only do certain kind of work. I mean, you're going to hear during the course of my career that I evolved, and most engineers that I know also evolved. But at its core, mining engineering looks at the physical reserve of whether it's like coal, or whether it's a metal like copper, or whether it's iron ore, whatever the kind of mineral it is that is being mined, looks at the, let's call it the topography, how far beneath the surface it is, how thick the seam is, what the conditions of the land are around it, how you're going to extract it, what kind of equipment you need in order to do it. The trucks at the mine in Wyoming were at the time 170-ton trucks. And these are huge trucks, what the process is, and there are shovels and there are drag lines, and drag lines are actually huge shovels that actually move themselves. And mining engineers plan all of that. They plan and they look at how that reserve is going to be mined, and then where it's above ground, they actually plan the reclamation for after the mining, and that's where you return the land to its original condition.
Very cool. Thank you for describing that.
So in 1984, I went to work for Stone & Webster Management Consultants, and that's where I did consulting work using the planning background that I had gotten at Duke Power, as well as all of the fuel knowledge that I had gotten at Mobil, and used that to assist my clients, who were primarily utilities, but sometimes public utility commissions as well. And those are the bodies that are the state regulatory agencies that oversee the utilities. There's also actually federal regulatory agencies as well, and I've done some work for the federal ones as well, looking at and sometimes running the models for, sometimes looking at the models that the utilities had run to make sure that the results look right, then assisting them in the regulatory processes, which involved writing reports, writing testimony, giving testimony in hearings, and supporting their efforts in ways that they were interested in.
What types of things do the regulatory agencies oversee at power generation facilities, and do they also hire engineers to do that work?
I'll answer the second part of your question first, which is yes. There are engineers at state regulatory agencies. There are actually many engineers at state regulatory agencies. And what they regulate in the generation area, there are many different agencies involved. I was working primarily with the public utility commissions, sometimes called public service commissions. They actually, when a utility plans a new power plant, even if it's wind or solar, the utility has to file for a permit from the regulatory commission and many other commissions as well. But the regulatory commission permit is called usually a certificate of public convenience and necessity. And that process involves providing evidence that the power plant is needed at a certain time frame in the future, and what particular and the justification of why that particular kind of power plant was selected. So if it's a nuclear power plant, or it's a natural gas power plant, or it's a coal power plant, that it's the right size, that it's actually needed, and it's the right fuel. And if that is proven, then the Utility Commission issues a certificate of public convenience and necessity. And then after the power plant is built, and during the process of building the plant, there are many, many permits issued by the state, issued by counties, sometimes issued by cities, that are required, all of which involve engineers. And then after the power plant is finished, there's a rate case, which is a separate hearing that requires a lot of preparation and testimony. And the purpose of that rate hearing is to say, okay, this power plant is finished. It cost this amount of money. we thought it was going to cost X, it cost Y, because it's never exactly the same. And how much of that are the customers going to pay for? So it's a fairly contentious process during which citizens have the right to testify, and industrial customers and commercial customers and environmental groups testify, actually at both the Certificate of Public Convenience and Necessity as well as the rate case hearings. And then the Public Utilities Commission makes a decision as to how much money is actually going into the rate base.
Very interesting. Thank you. Do you want to keep walking us through?
Okay, so I was at Stone & Webster from 84 to 92, and then I went to work for a competing firm whose name at the time was Hagler Bailly, and I actually ran the utility planning practice at Hagler Bailly. I was there from 92 to 95 and doing the same kind of work, certificates of public convenience and necessity, and rate cases, writing and giving testimony, overseeing. I didn't run the models anymore. Someone else ran the models, and I oversaw the work. And then in 95, I went back to Stone & Webster as the assistant vice president in charge of the Denver office, and doing the same kind of work as well as all of the administrative stuff that came with running the office. And then all of those years, I'd actually also been a member of, from 1979 on, the Society of Women Engineers. And I had served on the corporate advisory board of the Women in Engineering program at the University of Colorado at Boulder. And the position of the director of the Women in Engineering program came open in 97, and I applied for it, and I got it. So from mid-97 through the end of 2000, I was actually the director of the Women in Engineering program as my full-time job at the University of Colorado at Boulder, and under a rule that universities have, which is called the 1/6 rule, and I don't know why it's not the 1/7 rule or the 1/5 rule, but it's called the 1/6 rule, and that basically says that 1 day a week you can do consulting work. So I still continued to do some electric utility consulting work while I was the director of the Women in Engineering program. And then in 2001, I went out on my own and I did the consulting work as an independent through my own business. The same kind of work that I'd been doing before. The planning work, overseeing the running of the models, doing expert witness work.
The Director of Women in Engineering program, can you describe that? What were your responsibilities there? I've never even heard of a university having such a position.
Oh, there are many, many universities that have women in engineering programs. I would say a couple hundred, if not almost all of the 350 universities that have engineering schools have women in engineering programs. And there are two primary facets of that role. One is to aid in recruitment of women students to the university, and the second role is to aid in retention of those students once they get to the university or college. And there's actually an umbrella organization called WEPAN, W-E-P as in Paul, A-N, which I think now, well, I'm not sure what the letters stand for anymore. It's gone through a couple of iterations, but Women in Engineering Programs Advocates Network, which is an organization where all of the women and men who are directors of Women in Engineering Programs can meet and exchange best practices and information through that organization.
Yeah, I just looked it up. It's Women in Engineering Programs and Advocates Network, and I'll put a link to this in the show notes as well.
Great.
So,
and so, I mean, my job was to go recruit. So that's to do outreach and to develop programs and to have students come in for sessions of activities, to go speak to high schools and middle schools, and then to develop programs and scholarships at the university to keep women students once they've enrolled.
And across these universities that have programs like this, what did they find helped the most in retention?
Well, the first thing that helped the most in retention was just to have the program. It didn't even matter if the students ever used it. Just because there was a program there, that was an indication of the university or college's interest in the women students. And my belief is that developing a sense of community is what those programs are probably most successful at. If you provide opportunities for students within a major to meet each other, to meet the women faculty, to understand the common experiences that they have, and for those women in engineering programs to support the efforts of the Society of Women Engineers collegiate sections at those institutions. Those are the primary ways that you lead to retention, in addition to the students just knowing that there's someone there they can talk to if they needed to.
Right. I know that a lot of the women at where I went to school for engineering, they really appreciated having the SWE chapter there, so the Society of Women Engineers group there, and it provided them a sense of community and support when they were struggling with their classes, and it really helps to have a peer there who says, oh yeah, I struggled with that too. This is what worked for me. So that definitely makes a lot of sense to me. Now, you served previously as the president of SWE at the national level, right?
Yes, I was the 1991-92 national president.
So talk to us about how you ended up in that position, and if another woman engineer was interested in, working her way up as an officer, what would you tell them?
I joined SWE when I was doing on-campus recruiting for Duke Power back in 1979. I'd never heard of SWE. There wasn't a collegiate section at the University of Virginia. I don't think I've mentioned on this radio show that I'm in the third class of women that were admitted to the University of Virginia under order of the United States District Court. And so I'm one of the first 10 women to graduate in engineering from the University of Virginia. You need 10 women to start a SWE collegiate section, and we hadn't heard of it at that point in time.
Wow.
So I found SWE doing on-campus recruiting for Duke Power Company at North Carolina State University in one of those gyms where their card tables set up at a career fair. And I was at one of the tables myself representing Duke Power. And during a break, I went around the tables and I saw the Society of Women Engineers, and I asked them who they were, and they told me. And I got a membership application and I applied. At that point in time, I lived in Charlotte, North Carolina, and there was a North Carolina section, but they were based in the Research Triangle area. So I didn't really become active until I moved to Denver in 1981. And I just I dove in pretty fast. I became the newsletter editor. I worked on outreach programs. I organized meetings. I think I was treasurer of what was then the Denver section. It's now the Rocky Mountain section. And by 1985-86, I was the section president. And I knew some women who were on national committees. And one of them said to me, her name was Connie King. Connie said to me, Jill, what I thought she said was, would you like to serve on the Awards and Recognition Committee and the National Committee? And I said, sure. But I missed the key part that she said, would you like to chair the Awards and Recognition Committee? I'd already said yes. And then I got a call saying, congratulations, you're now the chair of the Awards and Recognition Committee.
That's funny. That's all. You weren't quite voluntold, but kind of fell into it.
So I became Awards and Recognition Committee Chair. I think that was 87, 88. And then I was asked, as a result of the work that I did, if I would consider running for national office. And so I said, okay. And I ended up on the ballot in 88, I guess. And there were 3 vice presidents at the time. There were 6 candidates. I was one of the 6 candidates. And I was elected. And so I joined the national board. I served as vice president for 1 year, and then I served as secretary. And the woman who was president in 88, 89, I mean, the way she tells the story is different than the way I tell the story. But the bottom line is that I agreed to run for president, and that's actually a 3-year term, 1 year as president-elect, 1 year as president, and 1 year as past president, and I was elected. And so I think it comes from a lot of hard work and then doing whatever job that you are asked or volunteer to do very well, that you put your utmost in it and you make sure that it's done excellently, that you follow through on your commitments, that you do what that you say you're going to do, and then people come to see you as reliable and committed and elect you to be national president.
What are the most important initiatives to the Society of Women Engineers?
Today?
Yes.
Well, I'm a little removed from today, but I mean, a lot has not changed since women are still less than 20% of the Bachelor of Science degrees awarded in this country in all of the engineering fields together. We still have a lot of work to get to parity, and parity to me is 50% of the engineering degrees that are awarded go to women. And we still have a lot of work to do on retention. I mean, recruitment and retention are probably still the most significant things that SWE faces, ensuring that there's professional development or continuing development for the membership, and that we're role modeling and continuing to encourage girls and women to pursue the STEM careers.
Okay, so I want to talk about that for a minute right now. I looked up some numbers on women in electrical engineering in particular, and I'm looking at an article published by IEEE in 2008, and they reported, and I'll put a link to this in the show notes as well. So they reported that 12.4% of electrical engineering degrees, bachelor's that is, in 2008 were awarded to women, and that was a number that was going down, not up. And they also noted that computer engineering was even lower. Less than 10% of women were earning those degrees. So this makes for a difficult working environment at times. Could you talk to us about a time that maybe you experienced something difficult in your work life that was from you being a woman and how you handled that?
I will. I will tell you that when I attended the University of Virginia, backing up just for a minute in your comment, I knew there weren't very many women in engineering at the University of Virginia. But this was the 3rd year that women were admitted, my class. And so I didn't know there weren't very many women in engineering as a rule until after I graduated. And that's another reason that I joined SWE. I mean, people say silly things all the time. I've never really had what I would consider to be a horrible experience. I mean, I have had friends who've been physically assaulted, verbally assaulted, whose life was made completely miserable. But I guess what I've told my two brothers, my two younger brothers, and I also have a younger sister, is that I never would have made it through engineering school with just all of the ribbing and the taunting if I hadn't had two brothers who can dish it out worse than anybody that I ever met in engineering school, who still to this day torture me. And I'm 61 years old, and they are 58 and 55. And I mean, one example, and I now actually regard it as a funny example. I was in a meeting at a client that will remain nameless, and there were 12 men and me in the room, and this would have been about 1993 or 1994. And the two of the men were from an outside vendor, and then I guess the rest of the men were from the company, and I think maybe their attorney was there. And the two men from the vendor wanted to build a power plant, and they wanted the utility to buy the power from this power plant. Except they couldn't really decide during this meeting exactly which state it was located in. This utility served in a corner of a state, so they actually had service territory in 4 states. They couldn't figure out what state it was in. They couldn't figure out what fuel it was going to have, and they couldn't figure out how big it was going to be. And they're having this meeting with this utility, and they just keep vacillating on what all these very important decisions and parameters are. And finally, the CEO, and I didn't mention, I mean, these are high-level people in this meeting. So finally, the CEO turns to these two guys and says, "Are you going to make up your minds, or are you going to continue to be as fickle as a..." And then he just stopped, looked at me, turned beet red, and his name was Bob. And I said, "Bob, what are you going to do now?" And he just finished the sentence and said, "Woman." And obviously he was aware, as he was saying it, what he was doing and how he was going to do it, but he'd also dug himself a hole, and there was almost no way that he couldn't finish the sentence. And I don't view that as bad. I just view that that's kind of the over and over again kind of thing that I experienced. It's not bad in and of itself. Each little incident isn't bad. It's the cumulative effect of all of those little slights, or whatever we want to call them, that cause a woman one day when someone comes in and says to her, "You know, you look really nice today," and she just blows up, and they go back to their office and they say, "My, she's sensitive today." And it wasn't that she's sensitive today, it's just that that was finally the straw that broke the camel's back. And so what I tell people, and is what my friend Suzanne actually calls it, is rhino skin. Thick skin is not enough. You have to have rhino skin. You have to be confident and capable. And we can do this. Women can do this. It's so meaningful and such a wonderful career. But I spoke to a group of women doctors on Thursday night of this past week, and they told me the same thing. It's the same thing in law. It's the same thing in medicine. It's the same thing in accounting. It's the same thing. And so we just need to know who we are. This is what we want to do, and be confident in our capabilities and abilities, even when people around us question them.
Yeah, I wanted to go back to, you talked about making it to the vice president level at Stone and Webster in 1995. And that's a huge accomplishment to, as a woman in a STEM field, to make it to the executive ranks. That's a really big accomplishment. And I applaud you for that. For other women who want to climb that ladder and want to make it into those ranks, what type of advice would you give them, maybe in addition to rhino skin?
Well, what I did not say is that while I was at Duke Power, I also got my MBA, and I got it at night. And every job that I've had since that 1984 job, which was with Stone and Webster, has basically required both the engineering degree and the MBA. I don't think I'd be on either of the two corporate boards that I sit on right now if I didn't have the MBA in addition to my undergraduate engineering degree. And so what I say is that I've already mentioned in this interview that I think lifelong learning is important, and I think it is. I also think that formal or informal education, additional education, is also important. The MBA, leadership training, conferences, speaking at conferences, writing papers. I'm a graduate of the 1996 Leadership Denver class. What I learned in Leadership Denver is important for everything else that I've done in my life. So all of these opportunities, my friend Suzanne that I've already mentioned about rhino skin, she had the opportunity to go to the Harvard management class. Her company centered at Harvard, I think it was for 10 weeks. It was for a long time. And she had the opportunity to go through that. I've had my first husband worked for, it was called ARCO at the time, and they actually had a leadership training class in California, and they expected the spouses to show up too. That was one of the best leadership training opportunities that I've had. And so I strongly, strongly recommend this continuous learning and continual skill development. And I will tell you that I developed a tremendous number of skills through my volunteer work at SWE, where I learned to budget and I learned to motivate people. When you get someone to do something for you and with you in a volunteer organization, it is because they believe you and they want to help you. You do not have hire and fire authority over them. You do not have responsibility in an organizational form where, you're the boss and you say they have to do it because you're the boss. And so all of those skills from SWE were very, very important as well.
I completely agree with you. I think in these volunteer organizations, if you're able to motivate people to get on board with you, it says a lot, because they're not getting paid to help you with that. So I completely agree that involvement in these types of organizations is invaluable. I know that ASCE, the American Society of Civil Engineers, they have a program that young professionals can apply to go to a leadership conference. It's called the Emerging Leaders Alliance Conference. And there's several other groups involved with that. I think American Society of Mechanical Engineers, and there's a mining organization that's involved. Do you know do you just happen to know if IEEE has anything analogous to this for young professionals?
I'm not familiar with that. I know that IEEE does have a Women in Engineering subgroup, and there are many efforts through that arm to recruit and retain women in electrical engineering. But I do actually, now that you've mentioned the American Society of Civil Engineers, for our listeners, there is a book that I was involved in that I'm not the author of, Sybil Hatch was the author of, called Changing Our World, True Stories of Women Engineers. And going back to an earlier discussion that we had on this interview, this is a beautiful book. It is a fabulous book, and it shows how women contribute to, or engineers contribute to, chocolate and potato chips and brown rice and water and space and power and transportation and every aspect of our lives. So it's Sybil Hatch, Changing Our World, True Stories of Women Engineers, for people who want to see more about the broad range of how engineers contribute to our lives and how women contribute as engineers to our lives in a way that's actually beautiful and very readable.
Excellent. Okay, I'll include a link in the show notes for that as well.
Very good.
We're about to the end of my questions, so I'd just kind of like to open it up for you and see if there's any other, last minute thoughts or advice that you might want to give to young people who are interested in maybe pursuing an electrical engineering degree or a career in the power sector.
Well, I want to actually make it more broad than that. And there are so many programs that there are STEM camps, and then universities and colleges often have residential programs during the summer for young people to try things out. They have programs during the year where you can participate in hands-on activities. And I just encourage the listeners to check out all of these opportunities for both young boys and young girls to allow them to see what might spark their interest. I have another very good friend whose name is Sharita. Sharita had never, ever considered an engineering career. She grew up in the projects in Chicago, and she was tapped to go to one of those hands-on engineering career day kind of events and just fell in love with mechanical engineering. And she's very, very successful. She's a vice president at Comcast now. Very successful. And so there are so many ways to learn about these opportunities, and I encourage people to find out opportunities that might be located near them.
Very good. Okay, well, thank you, Jill. Thank you so much for joining us today. You covered so many great things. I'm going to put together show notes that will include all the books that we talked about and resources and some of the organizations. I'll definitely link to several things for IEEE. And gosh, just thanks again. I'm so glad that we got to have you on the show.
Well, thank you, Melissa. It's so fun for me.
Wow, we covered so much great information. Jill was a lot of fun to interview. I've got show notes ready for you at STEMxm.com/episode 1. That's STEMxm.com/episode and then the number 1. You can find links to all the books we discussed and the different organizations that we talked about with Jill on that page. For other resources or to get in touch, you can head on over to STEMxm.com, and you can also reach out to me on Twitter. The Twitter handle for the show is just @STEMxm Podcast. I'm also working on getting set up on some of the other social networks as well, so be on the lookout for those. Finally, if you feel like helping out the show, you can do so by making your Amazon, Kindle, or Audible purchases through our affiliate links, which you can find at STEMxm.com/Amazon. By making a purchase, after clicking through one of those links, we'll receive a small commission from that purchase. And this helps support the goals of STEMxm. So thanks again for listening. We really appreciate you, and we'll see you next time on episode 2.
This has been an episode of the STEMxm podcast. Thank you for listening. We would really love if you could pop over to iTunes and give us an honest, positive rating. It helps more listeners find us to learn about STEM careers. Thanks again, cheers, and we'll catch you on the next episode.